All right, in this video, we're going to talk a little bit about function operation notation. And notation is really just the way that you write something. It's the way that you notate what you're communicating. So when we're talking about adding and subtracting, if I've got two functions, and let's call them f and g, f of x means, hey, like this function has an input x, and the output is what happens to the x once, like when I put an x in, what's going to happen to it. So in the case of f of x here, like I put in an x, and it's going to take my x and multiply it by 3 and then add 4. That's the definition kind of what a function is. And then if I have a second function called g, well, let's say that I wanted to add them together. Like I wanted to take all of this and add it to all of this. Well, really, what you're saying is we're saying, okay, f of x, whatever all of the stuff of f of x is, plus g of x. And so what you'd do is you'd replace the f of x stuff with the 3x plus 4, plus, and then all of the g of x stuff, and replace that with x squared minus 5x plus 2. Well, mathematicians, right, like I'm not going to actually finish this problem, but this is in essence what it means. And mathematicians have generated a couple of ways of communicating this. One of those would be f minus g. You're taking all of f and f plus g. You're adding all of the f stuff to all of the g stuff. Another way you could write this is you could write it f plus g and saying, hey, like I'm taking all of f and all of g, and both of them have an input of x, and saying, hey, like that is this, right? You're taking f and you're adding it to g. And the same kind of idea applies to subtraction, except instead of a plus sign, it's a minus sign. And the way that you'd communicate that is you'd say f minus g, or maybe you'd say f minus g, where the input is x. Now be really, really careful when you do this. If you're writing f minus g, and I'll zoom out just really quickly, and I'll do the f in red and the g in blue. If I'm taking f, it's saying f is 3x plus 4, and I'm subtracting, oops, that went way too big, subtracting all of g. This is a big old subtraction problem, so x squared minus 5x plus 2, you'd need to be sure to distribute that before you simplify. So just a word of warning. So this is the addition and subtraction. Here, I'll go ahead and highlight it for you. This is the addition and subtraction notation, which is communicating, well, in this case, subtraction and addition of two separate functions. So here's a new idea that really carries through most of mathematics. It's called a composition function, and I want to introduce you to the idea of a composition function before we go ahead and do too much. So really, I drew this machine, and I want you to think of these as two separate entities, right? There's the g stuff, and normally in a function, input goes the x, output comes the y. But in this case, what we're going to do is we're going to take a value, it's going to go into one function, it's going to come out of the first function, and that's going to be the input into the second function, and then our final answer is what comes out after it passes through both. So what does that look like? Okay, so if I think about this, I'm going to do the work off on the side. If I think about this, if x is going into g, then that's really going to be g of 3, which is 3 plus 1. So 3 plus 1 we know is 4. Now 4 is going to be the input to the next function. So the next function is f. It's going to be f of the 4 from before. And then we'll put that into the function, and f of 4 is 4 squared. The output total is 16. So in essence, our x equals 3 has gone through the it's first gone through the g, and once it's passed through the g, it's now gone into the f and done its f business, and now it comes out total. So we call this as a composition function because it's going into one function, and then it goes into another function. And the way that this is listed is, if we were to write this notationally, we would say, hey, it's the biggest thing, it's first going to do its g thing, and then whatever that is going to go into, and here I'll do it in blue, whatever that is going to go into the f thing. And because in this specific case, the input is 3 instead of x, we'll go ahead and put in a 3 in there. So this is f of g of 3. And so that's how we say this. Now, I know this is a new idea, but just bear with me for just a moment, right? We're taking a value, it goes into G. The G stuff happens first because we need to know that before we can do the F stuff. Then the F stuff does second. We'll do another example. So what I really want to focus on here is what's the difference of f of g of x versus g of f of x? And notice the difference is that one is inside the other and the opposite. So f of g of x is saying that g is inside of f. So it's really saying that if I have an f instead of g of x, we're replacing the stuff that equals g. So we're replacing the stuff inside with x plus 1. And that means in my function f, where was the x is now going to be x plus 1. So we'll go ahead and do that. So it was x squared, but now it's x plus 1 squared, which we know to be x squared plus 2x plus 2. So we would say that f of g of x equals x squared plus 2x plus 2. So I hope you see that the g is actually like legitimately inside and going into f. We'll do the second one. In this particular case, the g is the biggest function. It's on the outside, and f is on the inside. So the stuff that we call f is on the inside. So instead of g of f of x is x squared. So we're going to take the function g, which has an input of x squared, and we're going to substitute that in for the x of the g of x. So g of x is x, so we'll put that in parentheses in red, x plus 1. But x here, the inside stuff, is x squared. Now, I'm not saying that this x squared is x. I'm saying in the function g of x, the input is called x. So the thing that I plug in is x, the thing that I plug in is x. Here, it's saying whatever it was, stuff plus 1, but the stuff is now x squared. And this simplifies a little bit easier, x squared plus 1, and that is equivalent to g of f of x. I hope that's connected. So one thing I wanted to show you before we go is different ways, because mathematicians don't always write it in this inside business. So these are three in the same thing. This is saying the big function is f and the interior function is g. This communicates the same thing, and we notate it with a little circle. It's not a 0. It's kind of tiny. It's about midway through the letter, f of g of x, right? And a more simple way of writing it would be f of g. So I hope this video was informational. We will do a lot more practice before you're expected to do a lot of this on your own, but I think it's good to be exposed to see. Rewind the video, especially if that f of x or f of g of x stuff didn't quite click. It's sometimes useful to watch this type of video a couple of times. I know for me as a math learner, it took me a couple of tries to really make this sink in. So it might take that long for you too. Thanks so much for watching. I'll see you in the next one.